All right, let's talk about binary numbers in JavaScript. Now, JavaScript has a set of operators known as the bitwise operators, and these are used to work with numbers at the binary level. So, binary, bits, ones and zeros, that's how everything is stored in memory in a computer. That's how communication is done. It's all streams of ones and zeros. So eventually in your programming, you're going to need to get to the point where you're comfortable working with the ones and zeros. Now, how does binary work? Well, we're all used to using the decimal system for counting. You go through the numbers 0 through 9, we run out of numbers, we add 1 to the next column, and we go through every combination again. We get up to 99. We've used every possible combination. Go to the next column, you get to 100. Then you use every possible combination of numbers in sequence up to 999. Then you have to add 1 to the next column to get 1,000. Binary works the same way. It's just in decimal we have 10 different digits. In binary there's only the two, 0 and 1. So 0, 1, we've run out of numbers, go to the next column. Do every combination, you've run out, go to the next column. Do every combination, you run out, you go to the next column, and so on. So these are just equivalent ways to represent these numbers. So the numbers that we're comfortable with and the numbers the computer is comfortable with. Just two different ways of representing the same number. So 0 and 1 are the exact same. Then when we get to 2, well, in binary, that has to be written as 10. I'm sure you've seen t-shirts, there's 10 kinds of people in the world, those who understand binary and those who don't. So we've got 3, 4, and you'll notice here over on the side what I've written. 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. Whenever you get to a power of 2, that's the point where it's jumping to the next column. So 2 to the power of 0, 1, 2, 3, 4, 2 to the power of 5, 2 to the power of 6, and so on will be jumping up by one column. And it takes longer and longer between each of these jumps. Okay, so that's how binary works. Now, in JavaScript, let's say we've got a couple of variables here, n and I, for number and integer. N, I'm going to put 10 in there. 6 is going to go into I. These are the binary representations of them. So 10, we just come down here, 10, yep, 10, 10, that's what it is. 6, it's 110. Now, something a lot of people don't know about the toString method is when you're converting a number to a string, you're actually supposed to put in a radix here. So you're supposed to put in the base. You want base 10 numbers, you want base 8 numbers, you want base 16, you want base 64, 32, or 2, binary. So if we run that, what we're getting, there, 10 and 6 is 10, 10, and 110. That's the binary equivalent of those two decimals. All right, now bitwise operators. This is how you can manipulate those numbers at the binary level, and there's certain things that we can do. We can AND them together, not add, but AND. And that means if I was to take, let's say, these two numbers, 10, 10, and 110, and I AND them together, what I'm saying is, look at every column. If you can find a place or places where both numbers in the column, both digits in that column are 1, the 1 will carry down. Otherwise, it's all going to be zeros. So that's going to be a 0, that's going to be a 0, this will be a 1, and this will be a 0. This is the result of ANDing those two numbers together. We only get one column that comes down, which means that 10 and 6 is going to give me 2 in the decimal equivalent. So let's write that out and see if we get that answer. N and I, that should give me 2. There it is, 2. Excellent, so that's working out. And 2 in binary, I guess I'll do it on another line here. 2 in binary, So the number, yeah, we'll do it like this, number 2 dot toString, and I want it in base 2. Oh, it's not going to do it from this string like that, because it already is a string. But there we are. And there's the binary version of 2. So it did give us 10. So if we just leave this as a comment in here, and then the result was 0010, which is 2. Okay, so that's the AND. And this is the AND operator. You can see that I used it right here. Now the OR operator, what it does is it takes one number and you give it another number, and it says look at each column, and if either are a 1, then we get a 1 in the resulting column, in that column in the result. So 1, 1, 1, 0. 1, 1, 1, 0, right there, 14. That should be our result. So log n or I, and there we go, 14. That is the result. So this is the bitwise AND. I'll wrap this in parentheses just to be safe. And this is the bitwise OR. I'll wrap this in parentheses just to be safe. Our next one, pardon me, is exclusive OR. Now the exclusive OR XOR looks like this. It's the caret character or caret character. What it does is it says only when one of them is a 1 do you carry the 1 down, otherwise it's 0. So if both are 0 or both are 1, it's still going to be a 0. So the exclusive OR, that's going to be a 1, that's going to be a 1, that's going to be a 0, that's going to be a 0. So that's 12, I think. Yes, 12. So 12 is the result of the XOR. So XOR with the caret character, caret character, N and I. There we are. The AND gives us 2. The OR gives us 14. XOR gives us 12. Now the decimal numbers at this point don't really seem that important. I'm going to show you something that you can do with them in a moment. So what we're going to do here is look at the bitwise NOT. What we're going to do first is look at the bitwise NOT operator. Now, the NOT operator, it's the tilde character, it likes to flip the bits, which sounds simple at the outset. So if I said NOT 1010, which is the number 10, my result you'd think of as being just 0, 1, 0, 1. So it's flipped the bits. But what it also does is it flips the sign. And when you're working with integers, you have a range. There's a positive to a negative number. There's a positive maximum and negative minimum. And when you're shifting things with the negative sign, what you actually end up with, so if I've got the number x, the result of doing the NOT operation is going to be negative x plus 1. So let's try this out. So bitwise NOT, I want to take NOT n, so NOT 10. If we look at our little formula, we would think that 10 becomes 10 plus 1 is 11, and the sign flipped. So this should give us negative 11. Let's Let's run this once, and there we are, not negative 11. Okay, now, something practical to do with this. Well, let's talk a little bit about permissions. This is something that I've actually done on a number of occasions. We're building a website, and people need to have permissions for doing various things on the website. And let's say that we're talking about the permissions for read, write, and delete. So there's some sort of data that they're working with, and a person can have any combination of these permissions. They could be allowed to read the data, they might be allowed to write the data, so changing it or inserting it, and they might be able to delete it. Or maybe they can read and delete, maybe they can read and write but not delete, maybe they can read and delete but not write. So different combinations of permissions. Now you could create 3 different variables and track these as 3 different Booleans, or you can use a single digit, a single integer to store all 3 permissions. And we do that by looking at the binary level. So if I was to take the numbers 0 through 7, this would represent every possible combination right here of these different numbers, of these different permissions. So let's say we've got this first column is the read column, this is the write column, and this is the delete column. So somebody with 111, somebody with the number 7, has permission to do everything. If they've got 110, it means they can read, they can write, but they can't delete. So if their number is 6, we know what they can do. If their number is 4, they can only read, they can't do the other things. If the number is 1, it means all they can do is delete, but they can't read or write. Now, we're probably never going to come across somebody who has that as a permission, but it's there as a possibility within this. So I have one value, one variable that stores the numbers 0 through 7, so I'm only using 3 bits, and that gives me the possibility to store 3 different permissions. Okay, so let's say, how would we work with this? How would I know if somebody's permission, let's say the person's number is, let's say 6. So my permission number is 6. How do I know what I'm allowed to do from that? Well, remember these powers of 2? That would give us the column. So if I wanted to find out about that middle column, I do an AND 10, or in decimal 2. AND 2 means that only this one column is going to come through. So allowed to read, that's this column here. The other ones are 0, so a power of 2, 4. So I'm going to do my permissions and 4. That's going to give me back either a 1 in this place or all zeros. So if that equals 4, I am allowed to read, otherwise I am not. So for the other 2 permissions, it's the same sort of thing. Read, write, and delete. I take my number, and I come in here, okay, 2, the 2 column, that was my right one. So if permission and 2 gives me a result of 2, I'm good. If this ampersand 1, permission 6 and 1 equals 1. So just to write a couple of these out in the binary numbers, what we're saying is 6 is like that, and 4 is like this. If I do an AND operation, my result here is going to be 0, 1, because they're both 0, 0. So you can see it comes out as the exact same thing. What if we took somebody who had 2 as their permission number, and we ask, are you allowed to read? Do the AND operation. These are both zeros. Only one of those is a 1. Only one of those is a 1. Only one of those is a 1. Therefore, this is 0. So we can even simplify this because 0 is the only falsy value that is an integer. So if I remove this part, like this, I know if this is anything other than 0, that it's going to be 4. And if this is anything other than 0, it's going to be 2. If this is anything other than 0, it's going to be 1. But if it's 0, it's false. So we're just doing AND operations. We're saying 6 and 4. 6 and 4. And that gives us a result of 0, or it gives us a result of 4. And you can try this with any number. It's going to work out the same way. The AND operator allows us to extract a single column if we use a power of 2. We can extract one single bit from that number and find out. And extracting the one single bit is another use for that. If you look at the last bit all the way down, you'll see it alternates 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. That's odd and even. Every number that's even has a 0 at the end. Every number that's odd has a 1 at the end. We can say for var c equals 0, c is less than 50. We'll do that. So we'll loop from 0 to 49. If c and 1. So I'm taking the number c, whatever the counter variable is, and I'm ANDing 1 to it. So basically I'm finding out whether or not the last digit is a 1. If it is, this is odd. If it's not, then I'm dealing with something that is even. Oops, I wrote my escape characters backwards there. There we go. Even, odd, even, odd, even, odd, even, odd, even, odd. It just alternates back and forth through every number, and you can go up to infinity and you will alternate between odd and even. So there's another practical use. If you need to find out whether or not something's odd or even, and 1 with it, you can find out if it's odd or even. So we've got permissions, we've got alternating things, odd and even. And the last bitwise operator that I haven't talked about yet is the shift left and shift right, or the operators, I guess, plural, there's more than one. So shift left, shift right. This has to do with taking this number and I shift it however many positions to the right or to the left. If I shift it to the right, what I'm doing is I'm cutting off. So let's take an example here. 10, 10, 10. So we take this binary number and I say that I want to shift it to the right 4 places. Well, 1, 2, 3, 4. I've shifted it over that many places. So my decimal point basically has come over to here. So this will become 10 or 2. If I take the number 7, 1, 1, 1, and I shift it 1 place to the right, we're basically getting rid of this last 1. It becomes 11, so it becomes 3. So just to demonstrate that, 7 shifted 1 place. I'm going to comment these out just so it doesn't fill my screen. There we are, 3. That was the result of 7 shift 1. Or we can shift in the opposite direction, shift left. We take 7 which is 111, and we shift it one space to the left, it becomes 1110, which is 14. Take the number 8, and we shift it one place. This is going to become 16. You'll notice that shifting by one decimal place to the left is the same as multiplying the number by 2. So try 7 shifted one place, and log out 8 shifted one place. 14 and 16. So this is the shift left and shift right. And a practical use for the shift is to extract parts of colors. We have hexadecimal colors. So let's say you've got FF3300. This is my hexadecimal color, and I need to get the green part of it. So I know that this is the red, this is the green, and this is the blue. If I need to get the green part, I'm looking for the green. So I will shift it over. Now, hexadecimal colors, these are 24-bit values. 8 bits red, 8 bits green, 8 bits blue. For the green, I need to shift 8 to the right. Then I need to AND with 8 ones. So FFFF gives me this. 255 is FF, which is 8 ones. Then the green. I'm not sure what the 33 is, but let's just make up a number. So let's say that that's the green value. And then I had 0 here, so this is going to be 8 zeros. Now I take this number, I shift it 8. Shifting 8 will leave me with this part. Now, from that, I'm going to AND with 1111, 1111. So you can see, if I'm ANDing with this, I'm only ever going to be able to get stuff that's under these ones or above these ones. These are all zeros, so none of this is going to come through. So I'm going to get the 1111. That is going to be the result of my ANDing operation. So that's going to be 0, that'll be 0, 1, 1, 0, 0, 1, 1. So there. By shifting 8 to the right and then ANDing with 255, I get the green part of a color. So that's a practical application. So let's say color equals 0x FF3300. There's my number. This is how you write hexadecimal numbers, by the way, in JavaScript. Start with a 0x and then you can write the number. So this is my number, and I'm going to say, so no blue will be equal to color shifted by 8. That drops off the blue. And then I want to get the green, and that's going to be equal to the no blue and 255. So that's our green. Use capital G, I should use that lowercase g. There we go. There is the value for green extracted, the 33. 51 is 33. So this is hexadecimal, this is in decimal. And if we want, we can say green dot toString in base 16. That should give us 33. There it is. So the 33, we extracted that from this color. So that's another practical application of the shifting bitwise operator. All right, so that was quite a bit of material, but I hope that makes sense to you, and I hope that helps you out in the future. Any questions, please leave them in the comments, and as always, thanks for watching.